or negative could be atrocious, piece of crap. So these can be learned statistically from, if you have a corpus of positive negative properties, this can be learned completely automatically statistically. And once you have learned them, you can go and edit those lists, and you can further narrow them down into different kinds of rules, and we'll see some examples of rules. So here, for example, we were looking at TV data, and I am trying to do sentiment analysis across a lot of different brands. So for Sony, what I've done is I've gone ahead and listed all the Sony models, because whenever somebody mentions a particular model number, they're also talking about Sony in general. So this is how I identify Sony. The next thing is we can associate that TV has following features, which could be things like design, picture adjustment, performance, color accuracy, sound, power consumption, things like that. And then if I look at any one of them, so picture adjustment, picture adjustment. So whenever somebody is talking about picture quality, image, quality of the picture, then they are talking about the picture quality. So till now I have been showing you very simple rules, but you could write complex rules. So now we are trying to identify when exactly the picture quality of Sony should be reviewed as positive. So here I am writing a very simple rule, and the rule can be pretty complicated. It's a full-fledged Boolean syntax. So here I am saying that if I see the definition of Sony picture adjustment, which we just saw there, all those keywords, within a distance of certain positive tonal keyword, which I showed you in the previous screen, in the same sentence, and in the context of Sony, where we are defining the context is currently a window of 100 words, then I want to analyze that the picture quality of Sony was reviewed as positive. So this kind of a rule framework, it gives you a lot of capability, because now that we are not only defining overall sentiment, which are purely these kind of things, I am also able to take a product and define explicit sentiment rules around the features. The reason this is important, because the meaning of terms changes by the context. So if I say something very low, if I just give you this term, you'll say that very low usually would mean negative. But if I say very low cost, then that's a positive. But if I say very low quality, it becomes negative. If I say very low cost, in the context of the components I'm using to build my product, it becomes negative again. So things are things can be very complicated, and the meanings can completely change based on the context. The only way to address these kind of requirements is through a rule-based system. So here, for example, like if I am trying to define a negative situation. So I am looking for a negative sentiment. So here I am saying that look for all the definition of Sony picture adjustment, but in the context of not of a positive keyword. So if somebody says the Sony picture quality is not great, then that means I have flipped the meaning. So finally, what it does is, now I can test some documents and I can see how the evaluation is happening. So just to conserve some time, I'm going to march ahead. So this is the main process of sentiment analysis. So here the key is the accuracy aspect, and the ability to address the accuracy comes by a combination of both statistical as well as tool. The next is content categorization. As I mentioned, the job of content categorization is to segregate content by topics or entities. So here the idea is we have a taxonomy. It's probably not very clearly visible. Let me jump into the tool itself. The taxonomy that I was showing you in the when I was drawing the charts, like different charts. So there is a taxonomy behind the scene. And here I have organized a TV taxonomy, which is organized by the types of TVs. And under those I see all the models. look at one of the examples. Again, it's a similar kind of environment. Means here, it's a similar kind of rule-based, but again, it also takes benefit of both statistical and rule-based model. But here, once the learning is done, you are completely in a rule-based model. And many of you, if you are aware of classification problems, you need to have ideal training documents to be able to train your categories. In real-world scenario, that's a very hard thing to do because a lot of times the content is talking about multiple things. So I just cannot build a training set which purely talks about DLP but not about LCD because people may be comparing two things in the same document. So once I have written all these rules, I can test documents to evaluate how the rule framework works. So it's an iterative process. So this one did not match. Yeah. So it's an iterative process where I'm defining my taxonomy and the hierarchy is determined by how granular I want to go, and the rules are determined based on the context. So in this case, it's a pretty trivial example, but you can think of it. If I was trying to model a category called business, business can mean very different for Sony, business can mean very different for SAS Institute, and something else for a completely different person. So the idea here is I am taxonomizing my content into different bins so that later I can segment the content by categories. The way I was showing you when we drilled down to Samsung, and then within Samsung we drilled down into, so within LCD we drilled down into Samsung, and within Samsung we were drilling down into 32-inch TV and 40-inch TV. So once all the content has been processed, we briefly looked at the data annotation part of it. So the next step is indexing. The content is all indexed into a search engine, which is a full-fledged search engine that allows you to slice and dice your content in many different ways. So here, the few very important aspects. The first and the foremost is the expressivity. I showed you some simple examples of using plus-minus syntax, typically like the way you would do on traditional search engines like Google and Yahoo. But you could also do something complex. The second example is showing you that I am looking for all the documents that mention at least 2 out of 4 words. And this kind of search is something you cannot do on traditional search engines. So you can think of you want to explore all the content where they are talking about at least 2 or more brands. So this is how the analyst can define very sophisticated search queries and filter down the results. The next is the filtering by attributes aspects. So in my example, when I was showing you that let's now fix my domain to all the content that was about LCD TVs and then LCD Samsung. You need to be able to filter your search queries, search results in fact, by particular aspects. The next is relevancy rank. We could rank content in many different ways. They could be ranked by the freshness, which is new, which is old. And there could also be the parameters of relevancy can be completely different. And the last and foremost is of course the performance and scalability aspect. So when I was doing the search queries, I also showed you the results. So typically whenever a search query is issued, that's another way for me to navigate through the content. I can go through those and then I can look at how this evaluation particularly happened. And then I can say, okay, I agree or disagree kind of thing. And I can update it. So as soon as so this is the overall quality. And as soon as I update, the index is updated in the background. So let me go ahead and update. So then when I am plotting the charts are automatically updated to reflect my changes.